All right. So you may have written the equation of other kind of like things in the past. For example, you know, we know the equation of, like, one of the common ways we see the equation of a line is like y equals mx plus b, right? That's like the slope-intercept form. Okay, for a line. Okay, right. Did you guys learn point slope form for a line? Is that ringing a bell? I'll show it to you here. It's like y minus y1 equals m times x minus x1. Did you learn that one too? Is it familiar? Maybe, maybe not. Okay, so if you don't know it now, you will learn it eventually. At least in calculus, you'll learn it. It's a very handy way to write the equation of a line. It's just a different way to write the equation of a line. It's point slope form. Okay. And this is kind of an introduction thing here to kind of show you. All right. You also maybe in the past have like written the equation of a parabola before. So maybe you had something like y equals x minus h quantity squared plus k. Is that ringing a bell? Like you would like transform a parabola, you know, up, down, left, and right. Okay, maybe you had like an A out here, and that would make the parabola like wider or narrower or something like that. Okay, and so that's like the graph. That's like the standard graph for like a parabola. Okay, and you know what I mean by parabola, right? The U-looking thing, or you know, it could be the frowny kind of face too, right? One of those bad boys. Right. Is that familiar? Yes? No? Do you remember, like, kind of remember seeing that? Yes? Okay. So that's, again, I think that's something new with Common Core. It doesn't. We didn't used to always teach that kind of thing, but that's that. Okay. Well, the circles also have an equation. Believe it or not, you can like write an equation so that your graphing calculator, so that you would, when you graph that equation, would graph a circle. Okay. And so the standard form. Okay, of the equation of a circle okay, is this. It's x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, and so that's kind of like our key, kind of big concept we're going to be looking at. Okay. And you might wonder, well, that is kind of funky. We have like x's mixed together with y's on the same side of the equation, and it's equal to some of this other number here, r. Okay, so we have like all these variables going on, so it can get kind of funky. But if you think about it, it kind of makes sense, because the graph of a circle, if you were to like graph a circle in the coordinate plane, is a circle a function? Would it pass the vertical line test? Yeah, it would not, right? Okay, a circle, right, if you graph a vertical line through it, you could hit it at 2 points. So a circle is not a function, and so therefore its equation is going to look a little bit, you know, funky from what we're used to seeing, because we normally are used to looking at like functions and stuff like that. Okay, and so that's why it's a little bit funky here with the x's and y's all mixed up together. Now, just like in, for example, slope-intercept form, right, when you have an equation written like this, we know, oh, that's going to be the equation of a line, and we can just look at it and say the slope is the number here in front of the x, and then this b is like the y-intercept, okay? Or for a parabola, you can say, this h means we're going to shift it left or right so many units, and this k means we're going to shift it up or down so many units. Well, you can see here there's an h and a k here, and that does have to do with like a left and a right kind of shift, all right? So it turns out here the point h comma k, all right, is the center of the circle. All right, x and y are obviously going to be our variables, but h and k are the center of our circle, is the center point of the circle. Anyone want to guess what r is going to be? It's the radius, that's right, yeah. And r is the radius. okay, of the circle. Okay. So that's it. That's all we're going to worry about right now, okay, those kind of things. So we want to be able to write the equation of a circle with that information. So let's do an example here. So let's say we want to write the equation of a circle with radius 4 and center -3, 6. Okay, so the equation of a circle with radius 4 and center -3, 6. All right, so again, the equation, well, we're going to use this standard form right here. So it's going to be x minus h quantity squared plus y minus k quantity squared equals r squared. Okay. All right. The h, right, is the x-coordinate of our center. Well, the x-coordinate is -3. So this would be x minus -3, which is really then just x plus 3, right? We're subtracting -3, so it's plus +3. We can just make that kind of like a lead change kind of deal here. Okay. Quantity squared plus this k is the y-coordinate of our center, so it's 6. So it just becomes y minus 6 quantity squared equals, and then r squared. So the radius, and this is where it gets a little bit tricky. You got to be on your toes here. The radius is 4. So r squared will end up being then 16. Okay? So don't do, this is a very common mistake. Students, if I ask them, here's the equation, tell me what the center and the radius are, your students will be like, okay, the center is at -3, 6, and then they look at 16 and say, and the radius is 16. But in the equation for the circle, this number is representing r squared, it's the radius squared. So 16 is not the radius, 4. 4 is the radius there. So that's why that's our answer. And that's the equation for the circle. Okay. There it is. Okay. Questions on any of that? All right, so I want you guys to try one then. So let's hear. Try write the equation of a circle with radius 3 and centered at the origin. Okay? Write the equation of the circle with radius 3 centered at the origin. Let's go ahead and take 2 seconds. Basic idea, except radius 3, so, yeah. Yep. Y minus 0 is just y, right? X minus 0 is just x. Yep, same thing, you could just if you want. Yeah, looks good. Cool. Yeah. Okay. So yeah, looks good. Okay, so I saw a lot of people there, and okay, I saw a lot like x plus 0, x plus 0 squared, y plus 0 squared, or x minus 0 squared, y minus 0 squared. That's good. Also, we could just put it as x squared plus y squared equals 9. Okay, and believe it or not, we can graph this in our graphing calculator here. So I'm going to show that to you here real quick, just so you can see, because it's kind of a different kind of thing. We don't always get to see circles being graphed in our calculator, so let me show you that. All you have to do here is, well, in order to graph something in our calculator, it needs to be solved for what variable? If we go to graph something, we have to solve it for what variable? Yeah, it's got to be y, right? Because when we type it in, it's got to be y equals. Y equals. So I have to solve this equation here for y, so how should I go about doing that to solve this thing for y? Any ideas? What should we do? Yeah, Hunter? Yeah, so we want to get the x squared off to the other side there. And left y squared equals 9 minus x squared, and then what here, Hunter?
Square root.
Yep, square root. Now, when we take the square root in an equation setting, square root of y squared is just y, but that equals plus or minus the square root of 9 minus x squared. Okay? Because there's a minus in here, we can't break that square root up, so this so let me just show you one other little quick mistake that students make. Okay, square root of 9 minus x squared does not equal 3 minus x. Okay, you might look at that and be like, oh, there's a perfect square, and we can just take their square root, and that's it. Not quite, okay, because you have that minus in there. If it were 9 times x squared, then yes, it would be 3 times x. Okay, so the square root of 9x squared does equal 3x. Really, I guess I should say plus or minus there, but anyway. But it does equal that 3x. That is true, but this is not true because it has minus in there. Okay. So anyway, let's go about graphing this. So how do we graph plus or minus in our graphing calculators? What do we do? Any ideas how we can graph plus or minus the square root of 9 minus x squared?
You go to catalog.
Okay. Is there a plus or minus symbol there?
Towards the very end.
Alright, I started looking from the bottom up, so let's see if I can find it. Ugh, mine doesn't seem to have it. Let me try again. Did you see it? Did I just miss it? See, but they're separate ones though, unfortunately. See, mine doesn't have, yours might have plus or minus, I don't know, but mine does not. So we can't do it with catalog. What we kind of have to do is kind of it's kind of lame. We just have to write it twice. We'll do square root of 9 minus x squared, and then we'll do negative square root of 9 minus x squared. We'll just graph two things. Okay? So y1, y2, here I'll kind of put it in the center there so you can see it better. There we go, better lighting. Okay? Graph it. And like I said, that looks like a football or an egg. That does not look like a circle. Okay? And this has to do with the resolution of our screen. Okay? So right now, the window on this screen, if I press the window button, the x minimum, the x maximum is negative 10 to 10, and the y min and y max are negative 10 to 10. Well, the problem is this screen is a rectangle. So to go from negative 10 to 10 from left to right, okay, it's stretched out more than the vertical negative 10 to 10 because that is more narrow. So to make it kind of like the correct ratio, I guess, of the sides there, if you press zoom and then go down to z square, that will square it up so it looks nice. And look at that. Oh, look at that pretty little circle right there. Okay, there it is. And so, of course, if you want to, you can stop paying attention to Mr. Whitmire right now and start playing around and say, oh, what if I change that 9 to like 16, kind of thing. It's like, oh, now it's a bigger circle. And if I wanted to, I could make 2 circles, 4 minus x squared, and then negative 4 minus x squared. And now I've got a bullseye. Okay, you can do all sorts of little fun things in there, right? If you mess around with it some. Okay? And of course you can do other little weird things. You can put a 2 in front and see what happens. Ooh, let me clear that out. And some interesting things happen if you just throw random coefficients in front. See, it kind of stretches out the circle some there, and you can play around with that some more. Let's see, let's try a 5 in there and see what happens. See, now we get more of an ellipse or something like that. Anyway, fun stuff. We're not going to talk about ellipses, though. That's saved for another class. Okay, later on we'll worry about that. But right now we're worried about these circles. So anyway, so you can see it did create a circle. All right, this little equation here, centered at the origin with radius 0, with radius 3. I guess I should have pointed that out to you here. So let's see if I can get that back up. 9 minus x squared. 9 minus x squared. So there's the center of the origin, and sure enough, 1, 2, 3 is the radius. 1, 2, 3. Okay, there's the radius there of 3. So it works. All right. So let's try something else, though. Okay, so now let's try another situation. All right, let's say the point 3, 4 lies on a circle whose center is -1, 2. What is the equation for this circle? So the point 3, 4 lies on a circle whose center is -1, 2. What is the equation for this circle? Huh. Well, okay, the only way we know to write the equation of a circle is that x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. So let's plug in what we know. H and k, we know those. H is -1, k is 2. Okay, that's the center. So we'll plug that -1 in for h, so it'll be x minus a -1, which is really then x plus 1. And then k is 2. So y minus 2, quantity squared. But then we're not told what the radius is, so we can't do that, so we're kind of stuck right now. We have the center, but we still got to figure out what that radius is. Ideas? Yeah, Evan?
Could we just plug in the point of the equation?
Okay, so you want to plug 3, 4. Where should that go? How do you know we can plug it into x and y? Not only is it just any point, though, it's a point that's on our circle, right? So that means it should make the equation of the circle true. And that's exactly right. We can plug 3 and 4 in for the x and y there, and that'll eliminate the x and y and allows us to solve for r. So yeah, good job, Evan. That's exactly right. So 3 in for the x coordinate, 4 in for the y coordinate. Okay, so 3 plus 1 is 4, squared is 16. 4 minus 2 is 2, squared is 4. So I get 16 equals r squared. Okay, and so we square root both sides. Now, oh my gosh. 16 plus 4 is 16. Come on, guys, new math. I'm trying to teach it to you here. All right, there it is. All right, square root of 20. Now, again, technically here, because I'm taking the square root in an equation setting, this should be plus or minus the square root of 20. But why am I not putting the minus here? Why didn't I put the minus? Technically, we're in an equation. I take the square root of both sides. I should have this be plus or minus. But why am I not taking? Why don't I have plus or minus out front? It wouldn't make sense for the radius to be a negative value. Exactly right. So, yep. So r is equal to the square root of 20. Can we simplify that at all? Simplify that square root? Yeah, Evan? Yes, 2 root 5. Right, remember the square root of 20 is equal to the square root of 4 times the square root of 5. And why do we break it up that way? Well, because 4 is a perfect square. It becomes 2 square roots of 5. Okay, just like that. All right, so there that is, 2 square roots of 5. So then our final answer is x plus 1 squared plus y minus 2 squared equals r squared. Well, if we just square that 20, that's actually just going to be 20 then, isn't it? Okay, so there it is. So we didn't really need to simplify the radius there because we're just going to end up squaring it back anyway. But there's the equation. Okay. Questions on any of that? Okay, have one more I want to show you here, and then I'll get you guys your assignment. One more kind of problem to show you. Okay. Next one. Last one. The endpoints of a diameter of a circle have coordinates of 7, -3 and 1, 7. What is the equation of the circle? Okay. Now I'll tell you right now, guys, the last question we just did and the question that we're doing right now, this is like one of the first lessons I would teach to my pre-calculus class a couple years ago. Okay, it's like day 1 or 2 of pre-calculus, which is the class after the next class you're going to take. Okay, it's the class right before calculus. This is like day 1 or day 2 of pre-calculus. I would teach this stuff. So we're learning it now. We're going to see it now. Okay, so it's kind of cool. Maybe not. You're thinking this is too much. Okay, I don't know. We want to write the equation of a circle. The only thing we have is that x minus h, quantity squared, plus y minus k, quantity squared, equals radius squared. That's it. Are we told what the center of this circle is? Nope. Are we told what the radius of this circle is? Nope. So, where do we start here? Ideas? Let's see if someone else. Anyone? All right, Tanner, we haven't heard from you, maybe.
You can find the radius by doing like the line formula.
Okay, the line formula. You mean
I just did the Pythagorean theorem.
a Pythagorean theorem?
Divided in like the line.
Okay, yep, that would work, and that would give you the length of the diameter,
Divided by 2.
which we can then divide by 2. Okay, so let's see here. So you did Pythagorean theorem there, so we could find the distance between these 2 points, basically is what you're trying to say then, yeah? Okay, so you did like what, 7 minus 1 quantity squared?
Yeah, I just did on the square root of 6 squared and
Okay.
10 squared.
Right, yep, okay, which ends up being 6 squared and then negative 10, but squared, so it's going to be the same thing. So it'll be 36 plus 100, and that's equal to c squared, which is going to be like our distance, I guess, there. And so that's going to be 136. And so then the distance there would be the square root of 136. But you said we have to divide that by 2, though, right?
Yeah.
Okay, so it's like, so the radius then is equal to the square root of 136 divided by 2. Okay, so that gives us the radius. That's good. So we can plug that in here. The square root of 136 over 2.
That equals on the square root of 34.
Oh, when you like simplify it down or whatever? Okay, it divides by 4. Well, actually, let me just do it. We can just do it this way too. If I square the square root of 136, it gives me 136. If I square that 2, it gives me 4, which will then divide. And let's see here, it gives us, oh gosh, 34? No. 32? No. Math off. 34. Sorry, you were right. Okay. 34. Okay, so the radius squared there is 34, but we still don't have a center. 100?
I mean, we know the side of the, we know the center of the circle, so could we just plug in like the x and y?
Ah, now that we know the radius squared, you're saying if we plug in one of these points and then solve for x or y? All right, we can try that. Let's see here. So
No,
which...
I mean, like, you can do like 7 negative 3 and make 7 x and negative 3y. Because we know the side of the circle.
Okay, right. Okay, good. So yeah, so we can plug that in. Let's see here. So let's see. So we know that the radius is 34, or the radius squared, sorry, is 34 for sure. The regular radius was root 136. So you want to plug in a point here. So let's try that. I'm going to do it kind of down here. So you want to try 7 and negative 3? Oh, shoot. Forgot to plug in the negative 3. And then minus k. All right, so we plugged in our point there. That's true. That is something we can do, because it's a point on our circle. But now what? We have two variables there. Yeah, so good thinking. It's something we can do, but it looks like we're stuck, right? It looks like it's not be able to go any further here. We have to like foil this out, and we still have like h's and k's all in there. And it's that'd be kind of tricky. So it's good thinking there, but it's not going to quite get us to where we want to go. We do have the radius, though, squared.
In between the x coordinate is 6, so if you add 3 to the 1, you can find the center point.
So we find the halfway point,
Yeah.
the midpoint. Exactly right. The center of a circle is the midpoint of the diameter, isn't it? Right? The diameter goes from one end of the circle through the center to the other end of the circle. On each end of that diameter is the radius, so half of the diameter is where the center is. Okay? And so if we just locate the midpoint here, which is what Tanner was just telling us to do, he said from 7 to 1, that's a distance of 6. Half of that is 3, so if we go 3 in, that means our center is going to be 4. Let me see here. I'm going to just do it this way. The midpoint formula, we can do 7 plus 1 divided by 2. We can do negative 3 plus 7 divided by 2, which yields 8 divided by 2 is 4. Negative 3 plus 7 is 4. Divided by 2 is also 4. So the coordinates are 4, 4 for the center. So actually all we have to do there is just that, is find that midpoint. X minus 4, quantity squared, plus y minus 4. Quantity squared equals 34. Okay? So, let's summarize here. Okay? Find the center. Okay? Find the midpoint of the endpoints of the diameter. Okay? And then to find the radius, okay, we can use the distance formula. Okay, or, this is something we didn't talk about here. Okay, so what we did first here, what Tanner had us do first to find the radius, that's what we had to do if we do that first. But if we find the center first, what could we then do to find the radius? If we found the center first, if I already had x minus 4 quantity squared plus y minus 4 quantity squared, and that equals r squared, what could we do at that point then to find the radius? I'll give you a hint. We already kind of did this earlier. In the earlier problem, didn't we have the center to start out and we had to find the radius? What did we do there? Okay, we had the center in our equation, and then what did we do to figure out what the radius was? Yeah, we plugged in the point that was on the circle. Well, here in this case, once we find that center, we have 2 points to pick from to plug in. And so either one should yield that radius. So Stephanie's right. So you can do it that way, okay? Or find the center and plug in a point. Yep, sorry. Okay, and that's it. Find the center and plug in a point. Pretty algebra intensive today. Lots of fun algebra stuff.